Hi everyone and welcome to our virtual meetup at AICamp. My name is David and I am a community lead at AICamp London. Just a quick start on what AICamp is. It's a global community of AI developers with over 400,000 people in lots of different countries, and we are in most major cities in the world. So what we want to do is empower all developers to learn and to practice AI from anywhere. And we're always looking for people and want to collaborate on topics, on venues, on sponsors. So just get in touch if that's anything that you can offer. And this is the London team. So today's meetup is hosted by these brilliant people. And we also have a Slack and Discord channel that we can make your community shout out for. So I have this QR code up just for a couple of seconds. You can join it, and we love to hear more from you.
Right. So, welcome everyone. Thanks for joining in your busy schedule on Friday. And I'm going to present my screen and give a thumbs up in chat. I can't able to see the chat, but give a thumbs up in chat. David and Tibor will be there. If you all able to see my screen, uh, David, help me on that. Yeah, and Tibor.
Yeah, it looks good.
Perfect. So if everybody is there, so let's start the session. This is the first session. We came up with an idea of agentic hours. I think David mentioned that it's an inaugural session. And if you see this, this is a kind of session where you can rest up for a whole month. We will help you with covering up the technical things, technical side of AI agents. It's all about AI agents and exploring trends, what happened with AI agents, and understanding what's evolving in this field. And more importantly, this session will be with humans who's going to build agents. So that's a specific of this session and why this session we started with. You get all your newsletter information at one place. You get all your what happened in this agentic space in this 1 month, what's coming in, what's in research, what's business is doing, what's commercial is happening, what technically, how to execute things. So all these things at one place, that's agentic hours. So with that, myself, Subhash, so I work as a field CTO for an AI automation startup companies, and I work as an advisor for multiple startups. And David is also part of whom we are presenting today. So what we are presenting today, and we have Tibor, as David mentioned, covered on earlier. So without any delay, let's start. So with this, uh, our session is the first session today for Agentic Hours. And what's the topic of the day? Because every Agentic Hours session will have a specific topic we cover. Maybe we are starting today for 2025. So we keep it very fundamental and making sure that we decode what is AI agents and its capabilities. And this is an evolving field, and 2025 is all about AI agents. So let's make sure that we help you to digest all the information and give it back these slides to you so you can consume it in a way that however you can that best fits for your work or your playtime with AI agents. So going forward, so before I step into the big picture, I want to take a moment and ask you a question. Like, when I describe AI agents, what comes to your mind? So type your answer in 1 to 2 words or 3 words maximum. Like when I describe or when somebody describes AI agents to you, what that comes to your mind? So just 2 to 3 words maximum. Type your answers. What is AI agents for you? So Tibor and
Okay,
David, help
coming
me
up on
on.
the
Yeah.
chat, coming hot.
Yeah.
AI secretary, workflow automation, AI
Workflow.
bots doing human tasks, automation
Mm-hmm.
on steroids, interactive environment interaction. Oh, that's interesting one. Bots, specific and outcome based, an LLM that has access to external resources. Being able to book a vacation for me. Awesome. And for
Yeah.
Rajesh, AI assistant.
Yeah. Okay. Let it come in more. So all you all have some kind of understanding. That's correct. But somewhere there's other understanding of what is AI agent in the field. So I'll decode that. And is there any other answer, David, or
Yeah,
waiting?
it's more coming in, Subash. Second.
Let
Let's
everybody
see.
type in. Feel free to type in. It's
So,
okay, right? No right or wrong answer, but we will help you to
ah,
understand better.
Okay, worker manager, specialist for specific tasks,
Hmm.
stochastic function calls, intelligence at the last mile, agency with actions,
3 words, huh? 3 words, yeah.
asynchronous robots doing what I need.
Okay.
What's this automatic SF? What's SF, Michelle? Business logic layer. SW, someone mentioned microservices. Someone said chain of thoughts thinking before running tools. AI worker.
Mm.
Someone said for loop over API calls to LLM, a software application. Someone said, more than just workflow automation. Interesting.
Okay.
Terminator, smiley face, and integration of multiple AI models.
Okay, excellent. There's a lot more to come. They keep typing, but a lot of information has been shared. I think that's a way. That's good. You everybody has a different opinion on that. So let's keep all this aside and let's come to some level of clarity that what is actually, because I hear this automation, AI workflow, and bots and all these things. So let us step back and look at the big picture. So it's whatever we discuss here, AI agents or bots, or specialized agents or whatever has been mentioned there, AI workflow, all these things comes under one umbrella. So what we are trying to achieve is an automation. Okay, we are trying to automate things, the human tasks or any a task that we consider to be done as an action. So the journey of automation is very important to understand before understanding the AI agents. So journey of automation starts with all manual, and we are moving towards, you might hear this term like autonomous, artificial super intelligence and all these things, but it all started with manual. I don't want to go from pre-era and post-era kind of things, but I want to give you a quick look at like how did this manual started. The manual is all about rule-based playbooks and BPMs. Then it has been evolved into RPA and rule frameworks and rule AI workflows and not AI workflows, the rule-based workflows and all these things. Then it has been described, it has been split into two. One is like predictive way of doing the predictive algorithms and all these things. That is machine learning algorithms, and those are kind of AIs. So then there has been an explosion of low-code automation tools combining this rule-based and kind of flow, yeah, workflows kind of thing. That's what they. If you see RPA, that comes into that nature of things. So machine learning is one thing which has been evolved in a phase of then the predictive learning and all these things has been evolved into a phase of generative AI. So everybody knows generative AI after ChatGPT, but there was things has been happened underground before ChatGPT, and it has been known commercially because of known to everyone because ChatGPT has been launched commercially. So in a nutshell, there was a predictive and generative, and when generative AI came into picture, into a hot topic, then we started seeing the co-pilots and AI assistant chatbots, which is kind of conversation chatbots. Chatbots were already there when RPA environment, but it's very static. Like it has set of things, and when you ask some question, you go back to those questions, and if it has the data, then it respond back. But a RAG is like kind of grounding with your LLM and grounding with your data, so it is making it more like contextual understanding and giving you the right information in more broader structure and making it more conversational. So now we are in a phase of AI agents, which people used to call as AI more autonomous or autonomous, but I'll explain you why, where are we in the autonomous phase. But the journey is still continuing. Like it goes towards AGI, which is artificial general intelligence, or artificial, then ASI, artificial super intelligence. All these things are in a way. So we don't know when it's going to come, but everybody says 2 years, 5 years, but we don't know anything. So let's focus on one thing today, that's AI agents. And with that, I need to step to the next slide, which explains, connecting to the questions which I asked earlier, what is AI agent is exactly. So everybody described like bot, AI workflow, and many, many other things. Technically, AI agents is a kind of application or a software entity is what you can think, okay? But what's special of that is it plans, that means it can reason, and also it can take action with the help of APIs or function calling or tools. It can do actions. It's a kind of think of like a doer, not a talker. So let's say ChatGPT, you give some information input, it gives you an output. But it gives you an output. It talks actually. But AI agents, if you've seen the ChatGPT recent release, operators, we will cover that. David will cover that. You give an input, it takes an action on that. Let's say I want to buy an umbrella, it will go to the website and find you that, are you okay with this umbrella? Can I book it for you? Then it'll ask for your card number and all these things. I think ChatGPT has released an operator yesterday. That was a great example of what is AI agents are. But we have to understand that what makes an AI agent possible today. So why everybody is in a hype? What made really the AI agents? There are multiple factors to it. Starting with the data, but models like reasoning models like GPT-4o and all these things, the context window, all these things have been made this AI agent possible, along with tools and APIs and the infrastructure, GPUs, TPUs are making it more possible today, having more optimistic view with everyone. Why going forward would be AI agents. So this you have to understand it very clearly, that why what made AI agents possible and what exactly AI agent is. But I want to step back again to take a breath, to make sure that you are clear with this distinction of what is rule-based and what is AI automation and what is AI agent is all about. So you should understand the difference between each, because most of the AI agent conversation I have, or people used to have with me, or I have with others, we get confused with these things. Like, what's the difference between rule-based and what's an AI automation? Because many people think that using LLM is itself an agent, but actually it is not. I'll show you why in the upcoming slides. But you have to understand like this. Rule-based is like, think of like you're taking an off for coming week. You put a out of office, that you are setting a rule. Actually, you send back the email, whichever email it comes in. You are setting the rule. Actually, it kind of deterministic. So you have to understand AI agent is non-deterministic. What we've been doing earlier is very deterministic. This is what it is. If this, follow this. So then comes an AI automation. AI automation is kind of using machine learning models or LLMs, grounding with LLMs. If somebody uses Gemini, you see that when you get an email, you see that there is a kind of icon there. If you click that, it'll help you to create a reply email for that. Right? So it's like a kind of AI automation, you can think of it. It could be grounded with LLM, or it could be with ML models. So it could be in that way. AI agents is more of like, for example, if I'm somebody is sending an email, I'm out of office, but it doesn't reply to that. Let's say user A replies to me asking that, hey, we spoken last week about a SOW. Can you send it again to me? So based on this, what AI agent will do, it will not reply that I'm off. I will find it for you, but it will go really and find it in my deck and make sure that it's sending to the right people. It has all the guardrails set. So it's an action taken. Okay, so it's not just responding, okay, I'll check it for you. No, I'll get you the SOW for you. So it's a kind of thing you can think about it. It's about taking action. AI agent is all about taking action. So it's how you have to look at it. So this is very basic. You have to understand this very clearly. So with this, we have to make a move with a very clear idea. I have to give it on like what makes an AI agent. Okay, we talk about AI agents, but what makes an AI agent? I told that it's a software entity. I said it's a kind of a function call, but I told that I said multiple things earlier. But what makes an AI agent? What are the components of AI agent? It has 4 components, key components. There might be 5 or there might be 6, but they are evolving field. But there are 4 key components. One is orchestration layer. The next one is models. It could be LLMs or it could be SLMs. I don't want to add more vocabularies here, but I want to make sure that you stick with LLMs if you want. Large language models and small language models, that it is. And we have tools and we have memory. But in a way that how conceptually it looks like, this is how the AI agent is composed. The 4 components, how it falls in place. It starts with an orchestrator where the user interacts or another agent interacts, which has set goals, prompts, reasoning, all these things will be happening within the way it happens here. The logic, the algorithm here, then it backed by the brain or the LLMs as kind of not a brain, but it has all the data and all these reasoning things there as well. So it's backed by that, and also agent has tools. Tools could be a database for memory, or tools could be API or function calling, could be or third-party service calling a different application. So those kind of things combined as tools in the tool set. So this is a component of AI agents. These are the components. So you have to remember that when you talk about AI agent, and you have to remember of that. So there is an agentic system. So there is a two terms. So don't confuse with that. So stick to AI agents now. Agentic system is a big picture. AI agent is a small thing, which is composed of all these components. So I hope this has been clear so far. With that, okay, I have AI agents, but how do I design the architecture for AI agents? What are the patterns looks like? So I want to get it over there. So AI agent architecture patterns has many patterns, but these are the four important pattern to always remember that what kind of AI agents you are building in your POC or pilot or production. You have to remember that what kind of agent it is. So what kind of architecture we are going to pick depends on use case, depends on your requirement. All these things are factors to be considered. But these are the four patterns you have to remember at the basic, at the very base level. So these are four patterns, starting with the reflection pattern. Reflection pattern is a kind of a feedback loop pattern like agent. The agent setup is there. There will be a loop, or there will be a feedback loop or reinforcement learning. So what it would do is it understands that what happens in the past, how it taken action, how it decided, and all these things. So it takes an action, it takes self-reflect and see that what are the things has been done in the past and make sure that it correct itself for the future. So with the help of LLM and all these things, it understands the context and make the future best as possible. It keeps improving. That's a reflection pattern. Then it follows with planning pattern is kind of, if you know prompting, we've been given a session on prompting, chain of thought prompting, decision tree, all these things, tree of thought prompting and all these things kind of. So planning pattern architecture is something like, it takes a structured approach. Whenever the agent operates, it takes a structured approach. It break down the task. If you see 4O model, there is something. If you give something, it runs in the backend. Like if you ask for one thing as a common goal, I need to go to Paris by next month. So it will break down the task. Next month, what are the dates available? Next month, what dates could be the possible? What's the cheapest flight available? What's the weather looks like? All these things it will break into tasks. It make a structure. It make a planning. Then it comes back to you. So that's a planning pattern of agent. Then tools use pattern. The tools use, I shown that we have the agent will invoke the tools and make that action possible and make that action happen. So you give so agent does an action, agent does a task. So it makes sure that it calls the tools, invokes the tools whichever and whenever necessary, and make that action done. So that's the tools use pattern. And most importantly, in the last section, you see this is the multi-agent pattern. So it's a very interesting topic. The multi-agent pattern is you can run one agent to achieve the task. Also, you can run multiple agents to run the task. I'll show in the demo. We have a multi-agent system, a small a quick one, but not a bigger one. But the multi-agent could be 5 agents, it could be 50 agents, or it could be 500 agents. But there'll be multiple agents synchronously or asynchronously or in parallel running their individual task, and collectively achieve something. Or it does in a way that how we define it. And there is another multi-agent pattern like master agent, and multiple sub-agents will be there. So you have to understand that the multi-agent pattern could be defined in a way that when we have multiple agents operate to achieve one single task or multiple goals, then it becomes a multi-agent. So this is a pattern, but this is to give an idea of fundamental that when you have an agent, what is agent, then how do you define agent into your architecture? So you have to understand these kind of patterns, how to apply that. And so you understand the pattern now. So how does the agent looks in the real world? How does the agent is built? Agent is built in multiple ways. One is like mostly I see people start with low code, understand the better how it operates and understand the logics and everything. Then they go with the pro code approach. I'll show you both. But this is a low code. There is a tool called N8N, which is a low code tool. I would not call it as complete AI agent tool, but it's an AI workflow tool. But it achieves what agents kind of way it achieves it. What we want to do as a use case. So here you see, if you step back and look at it, there's 2 agents. One is new search agent, and another one is a new summarizer agent. So I showed a conceptual architecture, and physically, what happens is here, you see tools like SERP API, which is actually kind of API which goes and does a Google search kind of stuff for you. And there is a Postgres chat memory, which stores all the information which has been captured by SERP API. And there is a LLM Olama chat model, embedded in it. So tools, LLMs, and APIs, everything you can see here. And what happens here is when the chat is invoked or triggered from the user on the left-hand side, the new search agent, let's say, for example, I say that, what's the top news for today? So it goes into new search agent, search all the news for today, and bring it back and compose it and understand the context and pass it to the new summarizer agent. There I have a prompt in the backend saying that out of 100 news, uh, only list me top 5 which is repeated and got viral today, which is very important or something like that. Then it gives, again, it takes the llama with the help of llama, it makes a contest and give it back to the user. So this is what actually it happens. But you have to understand that this is how the low code of agent building looks like. When we move to the pro code, that means actually doing the code level of things. This is how it looks in Crew AI. So uh, so, so in Crea, this is a simple use case where think of like a CRM system bombarded with a lot of emails from customer. There will be an email analyst who will check all the emails and understand that what's the purpose of this email. Then he forward it to the right team or right member and get back the response, something like done in a legacy way of doing. So this agent, what it does is it's tightly integrated. We defined it, what to be filtered, what to be taken into response. I think there is a voice. So this agent takes those things into account, and it has a tools and tasks from there. What to be done. So you see, this is the role of a senior email list agent. So don't take it into like coding, but I want to give you that how the feel of low code and pro code looks like. It's not a big deal if you understand the difference and know how to start it and where to start. And all these things boils down into one question. Maybe most of them will have, okay, boss, you have all these things. But when I go into LinkedIn or anywhere, I see a lot of sheets putting the tools and icons and everything. Which one I need to pick? So it depends on your use case. Again, consulting language, sorry to use that, but it really depends what's that you're trying to achieve, what's the problem you're trying to solve. Is really agent is something you needed. Actually, you have to define all these things before getting into this one. But if you have a clarity that, okay, I need to test something, I need to play with this agent, then I would say that start with agent frameworks. What is the agent framework? That's a foundation. You need to think about it. Then you can pick like a way of hosting, where you want to host, or what kind of memory tools you need to embed in to make your agent work. So you have to understand the agent framework. The agent framework selection itself a process. If you are having a toy kind of environment, you want to test it and play with that, then you can use Crew AI. You can use low code or Crew AI to test it. Crew AI still works for enterprise, I hear. So, but if you want to have it a production ready or a solid foundation, I think LangChain has doing better there, and LangGraph is also doing this very a fantastic job. So far, I've been working on that. So I know that it works well. So now PI data, Pythantic AI, those are coming up. So AutoGen, Semantic, there are lots. You can test it out, but don't test each and everything. Define your use case. What's the problem? What you're trying to achieve? What's that you're trying to achieve for a long term? How it will evolve? How it will scale? Everything has to be taken into factor. Then you have to pick a agent framework. So that's what side. Um, I want to make a stop here to say that building agents are beyond our limitation. There is limitless of agents we can build, but if you don't have the fundamentals clear, like from the infrastructure to models, what models you need to pick, what kind of infrastructure you have in the base layer, because most of the agent building, everybody thinks it's a greenfield, but what is going to happen is we build agents which will integrate with the existing system, right? So that has to be taken into account when you're building the agent. You are not going to build the agent and work in a box. It's going to integrate with the existing system. So you have to make sure that when you build the agent, you have these underlying things. POCs are fine, pilots are fine, but you have to keep this in count. I've seen in many cases that what worked in POC will not work in production because we don't take much of these things into account. We take simple models which had bias and all these things, or we use some rubbish data. Fine for some POCs and play with pilots, but actually, but not even for pilots, I don't recommend, but for playing with how it works. But you have to think about all these things. But agents are not everything. You will have a combination of RPA, you will have a combination of rule-based. Maybe in a scale of 100%, you might start with 10% of agents today, but that will scale up, and let's say in an environment there'll be 40% agent, then 40%, 60% is like rule-based, then they'll gradually scale the ratio. So this is how it looks like in future, but today you can start somewhere that I shown that way to start. So with that, I'm coming to the end of the session, like showing the demo of that, how the agent, what we discussed. So keep a reminder of what has been shown in earlier in the conceptual architecture. We will be connecting back this to this demo, what we have here. So I prepared a quick AI meal planner. It's a goal of this is to understand your medical condition, and they'll be giving you a meal plan for your medical condition, for your preference, individual preference. So I create two agents. One is dietitian and one is a chef. So dietitian process all your information of medical conditions and allergies, what you have entered, the user. And chef, it's a multi-cuisine chef, which is who understands the global recipes, and he will craft according to your allergies, according to your medical condition. He will craft and give you a meal plan. So that's how the thing is. So what I'm showing you is like it doesn't have tools, but I'll show you the code for tools. But it's a very simple multi-agent system which has a component like Streamlight. It's being built on Crew AI, which is an orchestrated engine, kind of, you can think about it. And we have used Mistral as a base model for this complete setup. So this is the overall. And going forward, I will just pause for a minute and I'll show you the demo quickly. All right. So I'll stop here. I'll go in reverse because the actual practical demo, sometimes it won't work. So, but I have tested it multiple times. This agent system is perfect. It's working, but I can't rely on it. So I just want to show you that how it looks like before this session. I tested it like saying that I have a low pressure, my medical condition is low pressure, and I have allergies of gluten. Then not, but I just put it over here. Then cuisines like European, and I said that preference, I'm good with anything. So I just asked to create a plan. It really created a plan with it taken low pressure into count. So it taken like low sodium, then it taken gluten into consideration. It made it like gluten free. So it made it like everything is gluten free that is addressed to low pressure. So these two boxes is done by it being taken by dietitian, then it given to the chef who is taking the medical condition, who is giving to chef, and chef knows how to prepare the meal plan for them. So so coming here, this is like my console where I have the code. I have two codes. One is like basic, which is what I shown. It doesn't have tool integration. It just tell that if I give my medical conditions, what I shown, it'll give a meal plan. So it's very kind of two agents working in parallel. But I have also, it's a code. It's a Crew AI. So basically, what I'm doing is like I'm importing the modules. Then I'm defining my LLM. I'm using a local Olama based. I'm using a Olama. On the top of Olama, I'm running this Mistral model, a small language model. From the Mistral, I picked a small language model. Then I define the agent, two agents. One is dietitian, and I define the goals of that agent. Then I define that what could be the backstory looks like for that goal and the agent. And I had a chef agent, which again has certain goals like generate 4 days meal plan. I don't want to generate, if I say generate meal plan, it doesn't know, it keeps on generating. So I just want to put a loop there, put a stop there, define very specific that how many days meal plan. So this given that very good clarity to the agent that what's the agent is, what's the role of the agent. Then I said that these are the tasks you need to do for that agent. So I define the task. I said that collect all the input variables from the user and put it in a way that it should be displayed in this table format. So that's exactly what I want. So I defined it over here. It's a very simple code logic. And I have a Streamlight application, which is a front end, which I shown you. I've defined there that how the structure should be, how the layout should be. Then I close all the functions. So so this is how the basic Crew AI looks like, but we can still expand that. And coming, so I'll stop here and I'll show you that I've shown you, but I'll show you that how I'm going to run this agent again. So I'm going to run the Streamlight app, the basic app. Actually, it's here. The code is over here. I'm going to run that. So it's going to pop up for me the window, and it will start showing me the. Okay, it's going to pop up. Yeah. So you see here. So it will start generating the meal plan. It opens the application. I haven't. So the next step of this is a couple of things. I'll tell you. I'm converting this into a Docker file, converting it into an application. You can run it anytime. You can call that application. So here it comes. The application is live. So I say that medical condition. T1 I'll say that pressure. Let's see what it takes. Can be low pressure or high pressure. Let's see how it takes. Allergies, diary, and cuisines. I'll put Asian or Middle East and see that how it looks like. And I'm a veg. Let's generate this meal plan. So it's going to start generating the meal plan for me. And so it started. So there is a Olama running in the backend. So I have this server running. So you see the runner started, and I have the code which has been triggered. So it actually going to do the same thing you see here. So I ran it this one, it's going to do the same thing. It's going to generate that, then it will update in the Streamlight application. So it's still running in the backend. So, but I want to show that what's happening here in the premium. In the premium, what happens is like in the premium version of the same app, I'm going to inject tools, databases, and all these things to enhance the app which I shown. For example, this app is just generating the meal plan. So tomorrow I want to learn the user preference. This is one time you can generate. But let's say I'm having this regularly using it. So I need I need a memory to understand and keep a record of what I was asking every day and what I was chatting with this meal planner. So it keeps a memory. It has a database for that. And so sometimes I need a calorie calculator. Maybe I will ask sometimes like I need to reduce weight or I need to increase weight. All these things can be done. I also try to add one more thing, like it gives a meal planner, then it goes to YouTube and search for the short videos so that when I click the meal planner, the particular meal, I know how to cook. So I can keep I can keep a phone on the side and I can start cooking because there's a video running on. So those are the factors. Those are the enhancing factors or features we can do for the basic app which I've shown. But this is limitless. You can keep expanding that. So if you see, I have added the classes here. And I mentioned that what are the classes will be doing and what it will be calling. So if you see here, you recall this memory of the conceptual diagram which I shown. So we have an LLM here. We are defining the class. That's where the tools and function callings, actually the function calling is happening. Then we are defining what is the LLM and what's the model of that. Then we are telling agents what to do. And again, it falls into same what I shown earlier in the basic. Then I'm defining it like what could be the Streamlight front-end application. The same thing falls into here. So to show the difference that how the basic and premium looks like. Basic means very basic function. It doesn't use tools. So premium is like it has tools and function callings and all these things. So there is something happening in the backend. So let's not wait for it. I've shown it, but it's going to run the actual meal planner in the back. So finally, so back to the slide. So with that, I want to just touch on like, okay, you shown me a toy, how it works, but what actually it looks like in when you want to get into production or when you want to get into a real pilot in your organization or in your project. So you have to take multiple things into consideration. Like it should be in a spectrum. It should be a spectrum. It should not like picking a framework, you start doing these things. No, it won't work in that way. So you have to understand what's your problem, what's your use case, and all these things you have to do here, define and design those things. That's very important. Then understanding that very, very clearly, you have to put a lot of time here before getting to agents. Do you really need agents? Can it be done without agents earlier? So you have to be asking a lot of questions internally with multiple teams, data team. Do we have the data? All these things to be asked, and it comes to actually the framework and tools and all the. How do you start building? How do you start building your pilots and show and measure and all these things? KPIs. What are the KPIs? You will set up everything here. Then you pick up tools. Do you need memory or do you need? So this is very important piece. It might be going in the flow, but data comes the friend. So when you start building, you are actually validating the data. You are working with the data. Then it ends up in testing, monitoring, and refining. But I need to call out for a minute. Like, it's not about testing in agents. with agents, it's going to be more simulation. You will not be testing like how do you test your entire application or applications today. It's not going to be testing. So it will be a combination of testing and simulation. What's going to happen with agent? So agent testing will be changed into simulation. So you have to remember that you have to simulate a lot. You have to see fail safe option, or you have to control it. You have to see how much autonomy you need to give. So for an agent, if it has been given full autonomy, it can a small thing can break many things. If not given autonomy, then it's then efficiency. You don't want to use agents. You can use some other rule-based automation. So I'll cover that in the final slide of mine. Then David will take over for that, and we will have a question and answer in between. Yeah. So agentic practice. When you do an agentic practice with all those approaches of what I have shared, the agent comes with a lot of challenge. Okay, it's an evolving field. I even don't know certain things. Everybody doesn't know everything. We are still learning each and every day. Yesterday there was new information. While I'm talking, there might be a new information. We have to keep evolving with that. But we have to make sure that agents run in a dynamic environment, and we have to make sure that the feedback loops are there. To address those, mitigate those challenges. And as I said, autonomy and control should be well balanced in agents. If it's not well balanced, let's say you don't give any autonomy, you just run the agent and it comes back and you always ask something, then it comes back, then no use of agent. You can ask the kind of a simple automation, you can do that. So you have to understand that autonomy to be given at what level, and you have to make sure that it's like human in the loop as much as possible, at least for some time. So autonomous is considered of multiple levels to me. Okay, you take us the self-driving cars. So there is a multiple level of autonomy. You see in the robotaxi now with Elon Musk launched, there is no steering wheel. But when Tesla started, when there is an autonomous vehicle, there is still steering wheel. So you still need a human to control. So agents are in that early phase of things. So you still need a human in loop. So you have to understand that you have to define that what level of autonomy the agent could have, the agentic system has what you're building. Then you have to think about really about scaling. Somebody mentioned about microservices and all these things, right? So microservices and all these things, the cloud native architecture, what we built on is already a lot of breaking points are there. Now you are going to build on top the agent. So you have to be very, very careful of how do you define your architecture, how do you make your architecture work. And most importantly, I want to close it off like security and trust is very, very important. Beyond jargons, when I talk about security, many people in development, they think about like security is an outside, it's not inside. Actually, security is look after firewall at the firewall level, not inside. But with agents, security is going to be very much important on the internal than the external. The external is important, but you have to understand that internal agentic architecture needs more security because you don't know how many guardrails you need to put. Because, for example, there was a case like a couple of days back. I said something, and the agent went on the loop. It whole night it ran and completely eaten my GPU. That's one use case. There was another thing. It generated a code which was like hitting the DB and it crashed the DB. So you have to make sure that agent security is very important. First, as an inline, you have to work inside out. The outside in, it's already there. So there is a security team who's working from outside in or internally, but agent who's developing agent has to start with some level of security knowledge. That's very important. So in a nutshell, what I'm trying to say is like when you design your agentic architecture or agents or you play with it, make sure it's modular. Okay, and make sure that you are simulating it. Okay, yes, you need a testing, but make sure you are simulating it and make sure your data is continuously learned or updated for the agentic system. Let's say agent is behaving on something today, you're not updating the data. After a few days, the user is asking some other question from a new perspective or new thing. Agent doesn't have the data, so it acts on the old data, then there'll be a friction. So this is a lot of things has to be kept in place. People talk about autonomy, people talk about agent, fine, but there are a lot of things has to be taken into account to make agent operational. So more importantly, agent should be reliable than being autonomous. So you have to be very cautious on picking that it's not becoming autonomy of agents, it's to be more reliable. That's a message I want to take it as a takeaway for here, along with all those things what I described. And with this, I will stop here for question and answers, and I'll leave it to David to close it off with some nuggets and takeaways.
All right. Thank you, Subhash. That was superb. And really love the demo. We got some questions on the demo. I just want to bring up from Jason. So let me see his question. So Subhash, I think he raised an issue about, are you testing the outputs for the demo to make sure that the responses are correct? And he goes on to give an example here. So he said the meal plan, if you're looking at gluten-free, there is an output that says beef stir fry as well, but beef stir fry does contain flour, which is not really gluten free. So
Yeah.
I guess concern is that what would you do to test, and what's your thoughts on that?
Yeah, so this is where I purposefully made that one because there is a mistakes as well. I given vegetarian before testing, before doing this one, I given vegetarian, but it picked non-vegetarian. So I'm refining my prompts, I'm refining my goals to the agent, a task to the agent very clearly that this is no, this is yes, go in order. And also I am working on another agent, which will be a guardrail agent. Will check the output before releasing it as a meal planner. So I'm just working on that premium version. So I'm thinking to enable that because there's a lot of chances that it may end up thing. So there will be another reasoning agent which will go check and apply that. Okay, all tick okay. Then you publish, you release the meal plan. So something like that. You can add one more validator agent, kind of. But it all have to be step by step. We have to enable it. So we have to make it work first, then see that what are the issues, then we have to enable it. So yeah, I'm testing it.
Awesome, awesome. And the chat's really fire. So shout out to Tibor for handling all the questions. It's really superb. Yeah, so we come to the time now where we have 5 or 10 minutes just to chat, get to know each other. If you want to post on a Discord as well, like link
Yeah.
up. This is kind of a virtual platform where you can network with other builders as well. So we would just want to give that space for everyone.
Yeah.
But keep the questions going as well. So meanwhile, while you're doing that, there's a question about, can you discuss optimizing the cost of running the workflows, and question mark about the token estimation?
Oh, yeah. So that's what I said. An example, if you remember, there was a use case where we were testing with the Colab using Google. Okay, so we didn't define cost, we didn't define anything. We don't know how much it is. How do we cost the agent is not clear. Everybody's exploring it. It's specifically around use case and the token limits and all these things are really challenging at this moment. That how to define cost with all these things. I haven't explored into deep of that, but I know that there is some way that we can limit the access, but that limit will define the efficiency of agent output. So a cost in this phase, I haven't done it, but many people are trying to define what's the ROI for agent is still under development. There's still everybody is exploring. I have worked on a couple of projects. Very hard to define that what could be the cost for that, but we can put some ring fence that this is the utilization it can do. But again, I've seen that it impacts the performance of the output. So there is a trade-off.
Awesome, like rapidly evolving. There's a question from Shekhar. So he says, right now I'm building a financial chatbot and I want to have two LLM models. The first one is for the arithmetic calculations, and then the second one is for contextual data. But you say, my problem now is I'm not really sure if like using the agent framework will actually make my chatbot more accurate or not. What's your thoughts?
Okay, so if I understand the question correctly, he need to use two LLMs, right?
Yes, that's what the question says.
He used two LLMs. I think I would say that I need to delve more deep, double click and go deep into it. But I would say that from the sense of understanding, this could be achieved without agent. You have to see how you could achieve without agent. So there is a tool called Route LLM and all these things which can route according to your calls, which has to be gone to this LLM, or if it's a more deep reasoning LLM, it has to go to that question. It has to go to that. So you can test it out and see that I don't think agent is really necessary. I think you're trying to build a RAG kind of system and you're trying to, or something like that, if I understand correctly, test it without agents. Don't complicate the things. So this is what happened. So couple of projects I worked, we directly fit in agents into the system. It doesn't work in a way that we anticipated. Okay, so we slow down. We see that what could be the possibilities. Can this system can be built without agents? Can this system can be built without LLMs or generative AI? So that's the way to look at it before jumping into agents and force fitting everything into like agentic system. So it doesn't work in that way. So you have to test it. For example, I said the route LLM. That was one case that I don't want to go into agents. I was able to achieve with a small use case what I can.
Okay. Any thoughts, Subhash, on the differences between CrewEye and LangGraph?
Oh yeah. So LangGraph is really, really good from an enterprise scale or large scale system when you scale it. Okay, I haven't tested CrewAI in the enterprise, but I did test it for our other process simple automation. So CrewAI is really good for starting point. They and CrewAI is also coming up with the enterprise version of things. They have integrated with IB and all these things. But LangGraph combined with LangChain is super powerful for large scale systems. What I've seen, but still everybody is almost in a way of testing. Maybe one or two companies like they're really doing it great, but everybody has that kind of fixing these things and see that which framework. But again, I worked in one of the projects. We started with LangChain, and now we have to integrate CrewAI. So that's where the confusion comes in. So it's a way that you have to pick one, go with that, but pick one solid. Like you should have a long vision that what's the end goal looks like. So based on that, you make a trade-off, which one you need to pick. Do a
Awesome,
pilot,
awesome.
do a pilot, yeah. Do a pilot and see that which is more comfortable. But low code is also coming in, but I haven't seen in production or any low code. Low code could be commercial way of doing, yeah.
Okay, and we can open the floor for one question if any brave soul wants to unmute and ask. Floor is yours.
Yeah. Hi, David. This is Stan here. Can I
Hi.
ask a
Hey.
question?
Yeah, go for it.
Okay, awesome. Yeah, Subhash, first of all, thank you so much for sharing your knowledge and so amazing. The project that you've created is pretty cool. So I was personally, I'm a data scientist by profession, and I'm working on a mental health app. So I was, yeah, it would basically be based on scaling something called as narrative therapy and trying to obtain the relevant data for it. So just in the mental health space, if you had to create like a an AI agent, then what are the top things that you'd keep in mind to make it just like relevant and useful?
Mental health is more complicated than the meal planner, actually. So it's like you have to have a human values, and you have to make sure that I haven't worked in this mental health, but I can tell you I worked in a couple of healthcare. The most important thing is human values injecting into your agentic response is very, very important. That means it should not be biased. It will make the mental health more complicated. So that is one thing I can tell you again. So any use case, I make sure that you have the clean data, okay, and you have debias the data from, because mental health from a big picture quickly I can think even a small wrong data can make it worse, right? So you have to be very cautious when we are developing this. And I would say that ask yourself that what is agent purpose here? What's that agent is trying to solve? It is trying to take any action for that mental health. Yes, then we keep, or it's trying to take action in the front end or back end. You have to analyze all these things before fitting an agent into the case. So yeah, that's how I look at it.
Absolutely. I think that's great advice. Yeah, it is like directly customer facing. It would be interacting with the people who have initial symptoms of stress and anxiety and depression. So I think
Yeah.
yeah, we have to be like super careful in dealing, and one wrong output can really,
Yeah.
yeah, like cause mental health issues. So yeah, thank you so much for that.
It becomes worse, actually. It becomes worse because in healthcare, I've seen that HR data and all these things, if we have to debias it as much as possible, because that can make a significant impact or disaster when it goes wrong. But see, when we see in papers and all these things, when we see in quick demos and all these things, it works in a toy. But what I seen, the challenge is it doesn't works in a production like this. Okay, so you need to have a lot of people with the same line of understanding, same point of understanding understanding to make it work. So that's all I can say. So, and data, if it's rubbish, then it's your agent is going to act rubbish.
Do you think we can put any security checkpoints of humans? Even if
Yeah.
if I have a set of psychologists, who are like beta users for me, and if for some time, for a few months, I can have them do manual verification of the
Yeah.
outcomes. Do you think that will be helpful?
Yeah. So I said that don't think agent as autonomous. At least for 1 year or 2 year, don't take it as agent for autonomous. Make sure there is a human in loop. What layer you are giving autonomous is very important. For what task you are making it as autonomous is very important. So in your case, you are simulating and you're working with the humans. That is how you take the feedback. Then I said about the patterns, right? You go back and improve the pattern. You improve the agentic function. So it's a flow. Start small and keep gradually improving it. And humans are very important at this moment.
Yeah, absolutely agree. Yeah, thank you so much. This was very useful.
Thank you.
Thanks, Pen. And also in the chat, Andrew Tan and I myself as a ex-clinician, I say involve the clinicians early, get the psychologists on board just to know what is safe and the many loopholes that people can fall through. So just want to get that edge cases like covered. Yeah. Okay, so we're gonna have like 5 minutes left. So I'll just wrap up with the latest trends. And this is kind of a recurring thing that we want to have for this series. First up is Operator. This week, the huge news. Operator is the first AI agent released by OpenAI.
OpenAI.
Yeah, so very exciting. And what it is it's gonna use a VLM or a vision language model and controls your browser, completes multi-steps tasks in any website, and it gets to use the mouse and keyboard so as its tools, and then that it can do it without any prior integration. So in the demo they showed it can already order groceries off DoorDash based on a recipe that you want to cook, get Instacart groceries as well, and it's still rolling out to the US customers. So I think the important thing and quite interesting part is that they also have an evaluator model as well to balance out the actions that operator does. So at critical steps, it's going to ask you, hey, are you sure you want to buy this? Is this the right card that you have? Or do you want to purchase this ticket, which is like $300? So it's not going to straight jump into any sort of very crazy actions, but it's got a check and balance in there built in. So
Human in the loop.
yes, exactly. So yeah, that's Operator. We also have the other players like Gemini. So this is Google's kind of want to upstage that as well, and they have Flash 2.0, which is a focus on agentic works as well. So I've checked up. It's linked to this thing called Project Astra, and it is a direct competitor to Operator as well, but not released. But you can look it up. I'll put it on the chat. And also this week, Perplexity AI also released their agentic search and agentic assistance for Android. It's out already on the Android Play Store. I'm not affiliated, but they're also using a similar kind of agentic model where they have a VLM and look at what you're looking on your mobile device and also take actions for you. So the integration is not super yet, but as you can see, the big guys are pushing this out pretty fast. Okay. Yeah, next slide, Subhash. And just to top off the hour, we're gonna share our 3 nuggets. And this is gonna be something that we want to keep for a recurring team, but open to any new suggestions. So we have 3 links for you to look at in more detail after the call. If you want to learn more, these really great resources that we have compiled, especially for you. So maybe you can pull up Marketplace, Subhash.
Yeah. So the marketplace is like it's very interesting website. We are not the owner, but hats off to the owners. They have everything at one place. You can like check post. It's a bit slow for me, but yeah, you can take the specific and you can look into it. All the tools. So very importantly, let's not get tool biased, but you should know what these tools are doing, and you should know what are the topics the tools are. So you know that when you build the agents or when you build AI and all these things, you should know which to call in or what to use. Some are commercial, some are business to business. So you take a note of it. So this is one thing. The three takeaways what David was sharing. Every session you will get a three takeaways. That will be an interesting and very important to know. So it takes like 5 to 10 minutes. Let's say this white paper takes 5 minutes. You put it in Notebook LLM and go through it. And this is very important one, Anthropic, about the design patterns, about what is agents in very simple and clean language. So you can look at it. Thanks, David, for putting this together. Yeah.
Yeah, so just to add on marketplace, I think Chusin was asking about vertical agents. So these are basically, if you go to marketplace, you can see
I'm sorry. Yeah.
industries specific agents. So agents that are built specifically for sales and marketing, agents that are built specifically for content creation. I think that's kind of the trend where we are going, that you have industry specific, and that's what we call verticals. So before this, we have like horizontal agents or horizontal LLMs, which are broad, general purpose sort of ChatGPT is trained on all sorts of data sets. So this is
Yeah.
kind of the direction where we're going, the trends that we are picking up on for this year. Yeah. Yeah, so that's it. Did someone had their hand up on early on?
Yeah. You scan this QR code, join the Discord channel if you're not there, ask your questions, and join the virtual meetup group, right, David? So you can join there and we'll send you this deck. So you can use that for, yeah.
Yes, Paul. So we'll have all these in the Discord. We'll share the slides, and on YouTube, I'll make sure to post the links as well. Awesome. Yeah, so we're on top of the hour. Really happy to have everyone. And, at the top, we had about 106 or 109 people, which is really awesome. So I hope to have this as a monthly thing. We come in and spend an hour together, talk about agents, talk about like latest things that's going to happen, the trends and quick demos, network and share. Yeah, I see people posting at LinkedIn. So please connect, use the Discord, get in touch with your builders, your friends, and we'd love to hear your opinions as well. Awesome. Yeah, Subhash, any final words?
Oh, yeah. So don't get on the hype. Stay vigilant. Okay. Start small, play with it, then get confident, then move on. Okay. Hype cycle, don't get on that. It's not recommended now. So just start small. That's very important. Understand the conceptual architecture and see what you can do with that. And also don't force fit this AI agent into everywhere. It will backfire you. Yeah. I've seen that. I've got that. So let's not get into this. Yeah.
All right. So we top of the hour. The recording will be available. It'll be processed after this, and we'll get it up on YouTube as soon as possible. So give us a day or so. But yeah, awesome to see everyone, and we will catch you on the next month. All right. Take care and see you all.
Bye-bye.
Bye-bye.